All right, good afternoon, boys and girls. Today we're going to be taking a look at the distributive property. We're going to look at some visual models so that we can have a better understanding of what's happening with the distributive property. So first of all, the distributive property does not change our answer. It is one of our properties for multiplication, and it's just a different way that we can tackle multiplication problems. And as you boys and girls continue to get older, you're going to continue seeing the distributive property time and time again, and it will get more complex as you get older because you'll start throwing in variables with algebra. But at this level, we just want to see how we can perform our multiplication by using the distributive property. So recall that the distributive property combines multiplication and addition. Now it also does combine multiplication with subtraction as well, but we're just going to focus on addition for today. Distributive property allows us to multiply the number that's out in front of the parentheses inside to both of the add-ins, and those are the numbers we're adding up, inside the parentheses. So, for example, if we have 5 times 3 plus 4, that is the same thing as distributing this 5 in and multiplying 5 times 3 and adding that to 5 times 4. So it is the same thing as 5 times 3 plus 5 times 4. And if we do the math on both sides, we will end up getting the same answer. But before we do that, let's go ahead and look at some visuals to get an idea of what the distributive property actually is. So we have a larger rectangle. And if you remember back in, 3rd and 4th grade, we can find the area of rectangles by multiplying length times width. So if I have this rectangle here, let's see, this is 1, 2, 3, 4 units tall. And if I was going to find the area of the large rectangle, I would multiply it by its width. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units long. So the area, if I was to find the area, would be length times width, which is 4 times 12, which would be 48 square units. So, and if we counted all of these squares up, we would get 48. We would get the 48 square units. Now, if you notice, this larger rectangle is actually being broken up into 2 smaller rectangles. So we've got this purple rectangle, and we've got the green rectangle. The purple rectangle, let's see, is still 4 units high. 1, 2, 3, 4, 5, 6 units in width, which means the green, we can go ahead and count that out too. The green rectangle, right here, the green rectangle is also 1, 2, 3, 4, 5, 6 units wide and 4 units tall. So what we can do without adding any more space to this rectangle, without taking any of the rectangle away, what we can do is split it up into 2 smaller rectangles. And let's find the areas of those. So 4 times 6, well, that's 24. And there is 24 little square units here in this purple rectangle. And if we look at the green side, we also have 4 by 6, which is 24. Now it's a little tough to see, sorry. But if we add those together, 24 plus 24 gives you your 48, like we already knew we had. So this is a prime example of the distributive property, because what it tells us is that we can multiply the 4 by this piece right here, because we've got our 6 plus our 6, which gives us our 12. And again, this originally was our 12 units long. And we can break this up, and now we can use our distributive property. And we can multiply in, and that's going to be 4 times 6 plus 4 times 6. 4 times 6 is 24, plus 24, which gives us the 48, just like our original 4 times 12 gave us. So that is the distributive property using a visual model. Let's look at another example. Let's take a look at the large rectangle again first. So I can find the area, I can figure out how many of these little blocks I have by counting my length and my width and multiplying them. 1, 2, 3, 4, 5. It's 5 units tall. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 units wide. So I know my area will be 5 times 11, which is 55 units, square units. We can go ahead and break this up into 2 smaller rectangles, just to make it a little bit more manageable, because sometimes 5 times 11, the bigger your numbers get, the more difficult they get to multiply. So we can keep this on a smaller scale by breaking these up into 2 smaller rectangles. So this is 5 by 4, 1, 2, 3, 4. So if we do 5 times 4, we get 20 units in the purple or pinkish rectangle. And in this yellowish rectangle, well, let's see, we have 5 by 1, 2, 3, 4, 5, 6, 7. 5 times 7 is 35. Now, if we combine 20 plus 35, we get our 55 square units. So if we use our distributive property here, this would be 5 times the width, which we broke up into 2 pieces, 4 plus 7, because again, 4 plus 7 is 11. We can distribute the 5 and make this a little easier on ourselves. We can multiply the 5 in, and we get 5 times 4 plus 5 times 7. Well, 5 times 4 is 20. 5 times 7 is 35. We add those together, and we get 55, just like this original 5 times 11 would have given us. Let's do one more example just to make sure we're feeling a little bit better about breaking up multiplication problems using distributive property. So if we take a look here, we've got a purple rectangle and a yellow rectangle. So let's just go ahead and take a look at the small ones first. So this is 2 by 1, 2, 3, 4, 5, 8. 2 by 8, which is 16. If I multiply those, and then I've got, this is 4 wide and 8 tall. This is 8 tall by 4 wide. So 8 times 4 is 32. Now I'm going to add those together. So I know my overall area better be 48 because there's 16 purple squares, 32 yellow squares. So when you combine those, we get a total of 48. Now let's take a look at the top here. So if we look at this whole length, well, 2 and 4 gives you 6. If you add those together, you're putting them together. Now this is not a coincidence. 8 times 6, if we find the area of the whole rectangle, we get 48, just like we did when we had our 2 smaller rectangles. So using distributive property, this is what it would look like. We have 8 times 2 plus 4. We distribute the 8 in. That becomes 8 times 2 plus 8 times 4, which gives us our 48 square units.